When naming alkenes and alkynes, remember here we're looking at unsaturated molecules that have either double bonds in the case of alkenes or triple bonds in the case of alkynes. And the basic rule here is that we name our molecule based on the longest chain that contains either the double or triple bond, and furthermore, we number the molecule in such a way that the double or triple bond gets the lowest possible number. So for example, if I have a molecule like this, in which I've hung a methyl group on the second carbon, but I have a double bond way over here between the third and fourth carbon looking at it left to right, then I'm going to have to number this again, this molecule, I'm going to have to number it from right to left to give the lowest possible number to the double bond, which therefore puts a double bond between after carbon atom number 1. So I'm going to call this a 1-butene. I'm going to use the ene ending to signify the fact that this is a double bond. And since there's a methyl in this molecule also, I'll have to call it 3-methyl 1-butene. So in other words, what I've done here is I have numbered it in such a way the double bond gets the lowest number, that's why it's a 1-butene, and that throws a 3 as the locator number for the dimethyl, for the methyl substituent. Another important thing here in double bonded molecules is the cis-trans isomerism, and remember here that if I have a molecule that looks like this, where I have 4 different groups on my double bond here, I have to refer to this as trans 2-butene to distinguish it from the geometric isomer cis 2-butene. And notice here, of course, it's a 2-butene because I've got the double bond in the second position, whether I number it left to right or right to left. But I do have to distinguish between the cis-trans isomerism. In the first molecule at the top here, the 3-methyl 1-butene, there are no cis-trans isomers possible because there are both hydrogens at the end of on carbon atom number 1. On the other hand, there is no cis-trans isomerism with the triple bonded molecules, the alkynes. So, for example, in the case of 2-butyne, which would be written this way, then there is no possibility of cis-trans isomerism either. In fact, you'll hear later also that cis-trans isomerism is only possible in double bonded molecules and in cyclomolecules, molecules in which you find a ring, because there again the substituents on a ring might be on the same side of the ring or on opposite sides of the ring, and as always, the same side of the ring means cis, and the opposite side means trans. In fact, I forgot to put the cis 2-butene up here under that molecule.